for our semester final, it's going to cover everything we've done this semester. It's going to be about 50 plus questions. You'll have 2 hours to work on it. That means a little bit over 2 minutes a question. I was checking with some of the other classes as well. I don't know if any of you, like, if you're in an AP class, if your teacher has worked you through, okay, if you have 2 hours to take a test and you've got this many multiple choice questions, what does that feel like when you're working through? You have to keep moving. You can't spend 10 minutes on one question. But 2 minutes a question is usually enough for you to find the answer on these multiple choice questions, as long as you know kind of what to look for or how to work it out. If you're randomly guessing, there's a couple problems with that. First, if you're randomly guessing until you think you get it right, that can take a long time. Second, if you're just randomly guessing and putting an answer down, that usually means you get 25% on the test, right? 4 options, random guess, you get 25%. Maybe you're a really good guesser. Maybe you're getting 30%, 33%, slightly better than random guessing. That's not a good score on this final. That's going to hurt your grade. So you want to make sure that on each question you do the best you can, whether that is my suggestion, working the problem out, finding the answer, and then looking at the answer choices and finding the correct one, the one that you actually worked out. Or at least eliminating all of the ones that do not work for a variety of reasons, and then picking the one that's left over. So looking at number 1, if I'm just going to write the equation out, there's actually a couple correct answers. So you might get to the test and pick a question or pick an answer that's not there. You might have to do a little bit more work to figure out, okay, which of these is the same as my answer if I rewrite it, rearrange it. But let's go ahead and find as many answers to number 1 as we can. Does anyone have what they think is the A equation for number 1? Actually, before we even do that, what kind of graph is this for number 1? Linear. So you should be looking for an equation that looks something like y is equal to a times x minus h plus k. So did anybody find what they think is a answer for that one? So
y equals 1/2 parentheses x minus 2.
that is a correct answer for this one. So I'll use this point right here, the point 2, 0. Plug that in for hk. How do we find the a value for a straight line? You either use the slope formula of like difference of the change in y's over change in x's, or you just count up 1 over 2. Does that make sense to everybody? That's where the 1/2 came from. So if it doesn't have a 1/2 slope, that's not your correct answer. If this one isn't there, I would distribute it in 1/2 times x, 1/2 times -2 would be -1. If there was a number on the outside, it would combine with that -1. But this would be slope-intercept form. Same graph, but only rearranged. You can also get this one by using this point down here, 0, -1. If I plug that point in, y is equal to 1/2 x minus 0 minus 1. Does everybody see that that would reduce back to this one also? So again, that's the one we're looking for. That's probably the one that's going to be listed as an actual answer. But if you blank on the test and you're not sure which one is the correct answer, can't you also plug in one of these points into the different equations and see which one works and which ones don't? Now, there might be more than one that works. But if it doesn't work, if that 2, 0 point doesn't work in your equation, it's definitely not the answer then. For that equation is not the correct answer. Does that make sense to everybody? Use all the tools that you have to make sure you get the right answer on these. Let's do another one. Number 2. What kind of graph? Quadratic. So we know we're looking for y is equal to a x minus h squared plus k. Now, the people that wrote this test didn't pull any punches. They didn't make any easy questions as far as if they give you this, probably all the options are going to have a squared in them. There's not going to be an absolute value in there because they know you know the difference between a quadratic graph and an absolute value graph. What they are going to do is twist a couple of the points around. So what's the vertex for this graph?
Negative.
Right there, -2, 0. So you're looking for x minus -2 squared plus 0. So really, we need y is equal to a times x plus 2 squared. There might be an x minus 2 squared option. Does that make sense? That's one that you could knock out pretty quickly if you're being careful. But if you're just going through and saying, oh, it's a quadratic graph, that's a quadratic equation, I think it's that one. That's not much better than random guessing. You're going to want to be careful and check, because most of the options are going to look reasonable. Does that make sense? They're not going to give you stuff that's like, oh yeah, that's totally not it. You're going to have to do a little bit more work. You're probably going to have to find A. But there might be some positive A values and some negative A values. Can you eliminate some of those right off? Is A going to be positive or negative here? Negative. That's one where, like, if you're paying attention, you see that graph that's upside down, you can automatically knock out any of the equations that have a positive A value. So now, let's go ahead and find that A. I would plug in another point, say that one. If I plug in the point 0, negative 2, so negative 2 is equal to A times 0 minus 2 squared. 0 minus 2 is negative 2. Negative 2 squared. Negative 2 squared is 4. A times 4 equals negative 2. Divide both sides by 4. We get A is equal to negative 2 over 4, or negative 1/2. So my actual equation, what I'm going to be looking for is y equals negative 1/2 times x plus 2. Sorry, x minus 2. No, I did that wrong, everybody. I plugged in the wrong equation there. This is plus 2. This still ends up being the same there, but that should be a plus. And right here, that means this is plus 2 up here. There we go. That's the kind of thing, guys, if one of you called that out before I finished, you get some extra credit or some candy for that. Is everybody good that this would be the correct answer? Negative 1/2 x plus 2 squared. And again, if you had positive 1/2 x plus 2 squared, you could knock that out without having to solve for it. If you had a 2 times x plus 2 squared, or if the plus 2 is on the outside, if you're being careful, you can probably eliminate some of the extra options. But the safest, most reliable way of doing this is solving it yourself and then finding that answer in the option choices. Number 3, we've got an exponential graph. It looks like the asymptote's right here. And we had said if it's an exponential graph, y is equal to bx minus h plus k. This asymptote is your k value. And the point that is one above that, so right here, however far left or right that is, that's your h value. So this looks like an h value of 1. Y is equal to b to the x minus 1 plus 2. Now I need to solve for b. To solve for b, I can plug in another point, not this one, but this one up here, 2, 5. If I plug that in, 5 is equal to b to the 2, b to the 2 minus 1 plus 2. 2 minus 1 is 1. 5 equals b to the first power plus 2. Subtract that 2 from both sides. We get b is 3. So the equation there is y equals 3 to the x minus 1 plus 2. Now, you all are capable of copying down what I just did. Is that the best way of studying for this exam? just writing down whatever Mr. Kuntz writes down? Probably not. You really want to be paying attention and figuring out, why did I write that out? Why did I use the 0.25? How did I solve for B? If I do something and you're just writing it down without following along, that's not going to help you understand what's going on. You want to figure out, why did Mr. Kuntz do that? And if you're not sure, you should ask. Does that make sense? Ask me, ask the person next to you. And if you're not sure, again, and maybe you get it figured out at some point, make yourself a little note that that's something that you should probably study, something you should look over again and practice before the test. Again, just copying it down and hoping you're going to remember it is probably not enough to make sure that you actually remember it for the test. You need to be tracking, copying it down and following along, as long as you understand where everything's coming from and kind of trying to anticipate what's the next step. That's great. That's going to help. But just copying it down rotely is not going to be a great way of studying. Any questions about that one? Yes. One more time, sorry. The -1. And then did you say a different thing after that also? The -1 and 3? Oh, as the h value, okay. So the -1 is the h value. The trick that I had shown you guys for finding that one is the point that's 1 above the asymptote, however far left or right that was, that's your h value. So since this is right 1 from the y axis, that distance is your h value. Now, on the test, that one is probably the hardest to come up with the equation on your own. What if you don't remember how to find that h value, or you don't remember how to find b? What if you're looking at this graph and you see these 4 options? Y is equal to 2 to the x minus 1 plus 2. Y is equal to 3 to the x minus 1 plus 2. Y is equal to 3 to the x plus 1 plus 2. Y is equal to 3 to the x minus 2 plus 1. If I'm looking at these, I can take this point, the 2, 5, and plug it into each of these, and more than likely it's only going to work on one of them. Does that make sense? If it works on 2, plug in one other point into both of those, and it will only work one time. Does that make sense? So like, if I wanted to try this first one and see, well, I think maybe it's the y equals 2 to the x minus 1. If I plug in 5, 2, 5 is equal to 2 to the 2 minus 1 plus 2. 5 equals 2 to the first power plus 2. 5 equals 2 plus 2. That's a problem. That option is not the correct answer. Doing this is way better than random guessing. You're going to be able to really eliminate the different option choices and narrow it down to a single one. This, though, might take a little bit longer than the other way if you remember how to work it out quickly. If you're stuck and you're just kind of going around in circles trying to figure this out, this way may actually be faster, of plugging in the points and seeing which one works and which one doesn't. Both of those methods can be done in under a couple minutes. Does that make sense to everybody? As long as you remember what you're doing. The trick is, if you don't and you're just kind of like going around in circles, plugging in random things, not really sure what you're looking for, you can waste 10 minutes easily on a question and be behind. Does that make sense to everybody? Let's do another one. This one, way easier than the last two. Turn to the person next to you, tell them what the vertex is. All right, so class, what's the vertex? 2, 3, right? This point right here. 2, 3. Plug that straight in. Y equals a to the x minus 2 plus 3. Notice how the h value always becomes the opposite in all these different equations. So now, if I've got that, all I have to find is a. Now, I can count down 2 over 1 in either direction. Is this a value going to be negative 2 over 1 or positive 2 over 1? How do we know it's negative? Again, even just recognizing that is going to help you make sure you don't make any mistakes and maybe help you eliminate a couple options on your answer choices. So y is equal to, right there, 2 over 1, or negative 2 over 1, or just negative 2. Either way, if I do it this way, more than likely on the actual test, they're going to write it as just y is equal to negative 2, absolute value, x minus 2 plus 3. Is everybody clear with that one? Now we've got somewhere we're going the other way. But remember, it's multiple choice. If you can pull out that there is a point HK 1, 2 on this, you can eliminate any graph, any option choice that doesn't have that point on it, right? Does that make sense to everybody? And then even better, you've got the slope, 2 over 3. Count up 1, 2 over 1, 2, 3. If you get those 2 points, there's only going to be one graph on there that has those 2 points. We found that in like 20 seconds. It was pretty quick. Now, once you've got that, they're asking us for domain and range. Does this graph go all the way to the left, all the way to the right?
Yes.
So negative infinity to positive infinity. It's got everything. For the range, does it go all the way down, all the way up? Negative infinity to positive infinity. Or for either of those, all real numbers. For number 6, what kind of graph am I looking for this one? Quadratic. We should see a U shape here. So I'm looking at a vertex of positive 1, positive 2. So again, 1, 2. I should see that point on my graph. And then I know it should be a U shape. Should this U shape be going up or down? Down. That's probably going to be enough to eliminate 1 or 2 options, even just having the right vertex and having the right direction. But there very well could be 2 graphs that have the same direction, same vertex. So we'd really want to get one more point here. The fact that there's a fraction with a 2 on the bottom of it means I probably want to move 2 points over. Let's try plugging in negative 3. Y is equal to negative 1/2. Did I say negative 3? Positive 3. 3 minus 1 squared plus 2. Right, that's 2 away from my vertex. And if I work that out, 3 minus 1 is 2. Negative 1/2 times 2 squared plus 2. 2 squared is 4, so negative 1/2 times 4 plus 2. Negative 1/2 of 4 is negative 2. Negative 2 plus 2 is 0. So I plugged in 3. I got out 0. So I should have the point 3, 0 on my graph. And that is going to be enough for you to make sure you have the right answer. Right? And if I go the other side, I should have a mirror image point. Does anyone have any questions on that graph? Now how about the domain and range? The domain. Here, this one goes all the way left, all the way right. Negative infinity to infinity. The range, though. Do I have a maximum or minimum point on this graph? So everybody see the maximum point right there? At my vertex of 1, 2. Is my highest point 1 or 2? What's the highest value? 2, right? The y coordinate. So this is going from negative infinity all the way to 2, and that 2 is going to get a square bracket because it's an actual point on my graph. So depending on the question might be find the correct graph, or the question might be find the range. So if I'm looking at this and saying, okay, well my graph goes all the way up here to 2, but it actually gets there. That is a point on my graph. I need that square bracket. All right, any questions on the front page there? So let's turn to the next page. Questions 7 and 8. 7, I'm gonna hit 7 and 8 real fast here. I'm gonna tell you that 7, you should really move that 2 over, make this y equals negative absolute value of x plus 4 plus 2. The 2 was positive, so that it's easier to find the vertex at negative 4, positive 2. Negative 1, 2, 3, 4, positive 2. And then we know it's going down, that negative value right there. So we'd be looking for a graph that looks like this. Domain and range be the same as the last problem as far as finding those. 8, I'd be looking at the k value is 0. So that means my asymptote is at 0. And then I could either plug in points. That would probably be the easiest way. If I plug in 0 here, I get a fraction. If I plug in 1, 1 minus 1 is 0. 2 to the 0 power is 1. If I plug in 2, 2 minus 1 is 1. 2 to the first power is 2. That's going to be enough for you to get the right graph here. The domain, all real numbers, but the range for this one, the asymptote, I'm coming down for the range to 0, but I never actually get there. So it gets a parenthesis for the range. Is this sounding familiar to you guys? Some of it, yes. So there were some things I was going to skip. I can give them to you though. If you want to have this down negative infinity to infinity, that was not the greatest infinity sign. Negative infinity to infinity for the domain because it's going all the way left, all the way right. The range though is going to be negative infinity up to that maximum point of 2. But I have the point, so it gets a actual bracket. Now for number 9, are we good up through number 8? Numbers 9, 10, and so on, these are domain restricted functions. We're cutting pieces off, right? So my graph should only be between negative 1 and positive 2. So if I'm graphing this, it's just a straight line starting down at negative 2. If I plug in 0, right? You could always plug in points. Put in 0. 3 times 0 is 0. Minus 2 would be negative 2. Put in 1. 3 minus 2 is 1. Put in 2. 6 minus 2 is 4. And if I kept going, anything past that I'm going to erase, right? Because that's not in my domain from negative 1 to 2. And if I keep going the other way, coming down here, down 3, over 2, this one should be an open circle or an open dot. Open circle. Because of the just negative 1 is less than x. There is no or equal to there. Negative 1 is less than x. So my domain is going from negative 1 to 2. The exact same thing I had here. But the negative 1 with a parenthesis, the 2 with a bracket. Because of where that or equal to is and where it is not. Is this making sense so far? What about my range? Tell the person next to you, what's the lowest number? What's the highest number? How is this graph going? Do we agree that the lowest is negative 5, the highest is 4? But what about the parentheses and brackets? Parenthesis and bracket again. Open circle at -5. Open circle at -5 means a parenthesis. Filled in dot at 4. That means a bracket. Number 10, same thing, but for an absolute value. We've got our domain from -3 to 0. So normally when I'd graph this, I'd find my vertex, -1, -4, -1, -1, 2, 3, 4, and then I'd go up 3 over 1, up 1, 2, 3 over 1, up 1, 2, 3 over 1, and I could keep going, get as many points as I want that way, go up 1, 2, 3, back 1, 2, 3, back 1, get as many points as I want that way. But the trick is, instead of drawing this entire graph, I'm going to cut it off. Get rid of everything past 0 on this side. Get rid of everything past -3 on this side. Solid dots on the endpoints because they're both are equal to. The domain would be this same thing, -3 to 0, but with square brackets because of the or equal to. The range looks like my lowest value, -1, -2, -3, -4. Up to +2. Does that make sense to everybody? Now let's skip 11 for now. Instead, look at 12. Here's my dividing line at 3. On the left of 3, I'm graphing x minus 1 squared. Oops. X minus 1 squared. So that means my vertex is at +1. And probably just getting a rough graph is going to be enough here. 1, 2, 3. But if you want to be more precise, could get 4 or 5 points here. On the other side of the graph, this would normally be a absolute value starting down at -1 and just going up 1 over 1, up 1 over 1. But the problem is I don't actually want my graph on this side. So normally it would be right here. But I'm going to erase everything on the left of this red line for that absolute value graph. So I don't even have the vertex. And at the dividing line, it's going to be an open circle because, again, no or equal to there. So it's just going to be an open circle there, going up. There's my graph. Now the domain here. Does everybody see the 2 open dots over each other? I don't have a value at 3. There is no graph there. So my domain goes -infinity to 3, and then 3 to infinity. It skips over that point. But my range here goes down to to 0, and I have that point, and it goes up to infinity, and I've got everything above 0. 0 to infinity. Does anyone have questions on that one? Turn the page. On 13, there's a couple things here. Do they come up? They don't. There's a couple things here on 13 that are going to be on the test that aren't explicitly talked about on this review. Do you guys see any any relative maximums or minimums on this graph? What do you see? Say that again?
At 5,
5, 3 right there. Is that a max, relative max or relative minimum? Relative maximum. Is there a relative minimum also? Yep, right here. What about the endpoints? Can the endpoints be relative maximums or minimums? Nope, not for us. What about when it's constant? Can that be a relative maximum or minimum? Nope. This point where it's going up and then changes how fast it's going up? Nope. So there's only those two. I will tell you right now, there's a question on the test that asks you how many or where are the relative maximums or minimums. Does that make sense to everybody? How to identify those? And then when it's talking about -4 to -1, this section of the graph, what kind of graph is that? Linear. Can you guys finish that one? Okay, don't do it right now. I'm going to have you do it later. 14 and 15 are reflections. If we're going to skip anything, go ahead and cross off 16 and 17 for now. If you want to do them, it's good practice, but it's probably a little bit beyond what we're actually going to be doing on the final. What about, but let's go ahead and talk through 14 and at least. 14, x minus 2 squared plus 3 would mean a vertex at 2, 1, 2, 3. So we're looking at something that looks like this, right? Just a real quick sketch. What does the negative x do when I flip it? Which direction is this going to reflect my graph? So this is opposite x values. So it's going to flip left and right across the y-axis. So my vertex is now over here. This is going to be enough for you to figure out where the correct answer is on that question. Does that make sense? As long as you remember that a negative x flips across the y-axis or flips left and right. That'll be enough for you to find that answer. Turn the page. Graph the function and describe the transformation. What's the vertex here? 0, 0, right? This one's 0, 0. So if this one, f of x, is my starting 0, 0, and then I could plug in 1 and get out 3, or -3, or sorry, -1, get out 3. There's my parabola going up real fast. Whereas this one's vertex is at -4, -2. How do I go from f of x to g of x? What's the shift? Say that. Oh, sorry, I misheard you. You said that correctly. Left 4, down 2. Does that make sense to everybody? Left 1, 2, 3, 4, down 2. And that's what you're going to write. Left 4, down 2. But remember, it's multiple choice. So the options are going to be left 4 doesn't go up or down. Or it's going to be right 4, down 2. Or it's going to be right 4, up 2. Or it's going to be left 4, down 2, the correct one. Do you all see that if you graph it correctly and you actually count it off, it's easy. But if you're just looking at this and saying, maybe it's right 4 or down 2, I don't know. If you're just going to go real fast, not going to bother actually trying it and working it out, it's easy to make mistakes then. These last ones confused us when we did these originally. So let's make sure we've got this down. Does that make sense? So for 19, it says find f of whatever, using this piecewise function, f of 2. Where do I plug it in? Do I plug it into the top equation or the bottom equation? How do I even know?
The x and the 2 on the right.
Yep. Look at these two. 2 is right on the boundary, right? But one of them has the or equal to. So I'm going to plug this into the top one. 2 squared plus 1. Where this 2 is what got plugged in right there. 2 squared is 4. 4 plus 1 is 5. So all it takes is plugging it in and you'll be able to find that answer. That f of 2 is 5. Whereas 3 is bigger than 2. It's going in to the bottom one. 1 minus 3 times 3 squared. 3 squared is 9. 3 times 9 is 27. Negative 26. And the last piece here. This one says select all the statements that are true. It's the same as what you did up here. You're still plugging in 3. You're just seeing if the answer is negative 1 or not. So if I try that, if I plug in 3, do I plug in 3 to the top equation or the bottom equation? Let's try that again, class. Do I plug this into the top 3? Does it go in the top equation or the bottom equation? Bottom. It's greater than 0. So negative 2 times, absolute value of 3 minus 1 plus 3. So 3 minus 1 is 2. Negative 2, absolute value of 2 plus 3. Absolute value of 2 is 2. Negative 2 times 2 is negative 4 plus 3. Negative 4 plus 3 is negative 1. That one is true. It worked. Does that make sense to everybody? We've covered pretty much everything from Unit 1. I want you to, over the weekend, try to finish anything here that we didn't get to, other than maybe 16 and 17. Again, you could try those. The way this is going to work, if you turn this in and it's completed, besides the 2 that we crossed out, 16 and 17, you get 10 out of 10. Full credit on that homework assignment. If you just turn in what I just did with you, you'll get 7 out of 10. It's still decent, right? You'll still pass. But I want you to be practicing and trying the ones that we did skip. And then over the weekend, I would highly suggest that you get together with a friend and maybe talk through, how did we get that? Where did this come from? Try some of the old ones. Look through your old notes. Hopefully you still have them. We still have, like, what, 6, 8 minutes in class? So you could potentially finish it all right now. To be 100% clear with you guys, this test is not easy. Typically, students score slightly below what they've scored on their regular tests. Just a little bit. This final, though, is worth just slightly less than a regular test, okay? Because I think in this class our tests are worth 60 or 65% of our grade, and there's only 5 of them. So each test is worth about 12% of your grade. Your final is worth 10% of your grade. It's in its own category, but still worth 10%. So most of you, if you study, do well, you'll keep the grade that you have after I put in the Unit 5 test. If you don't push yourself, you may drop a little bit. If you randomly guess on the final, and you get a 25% on the final, your grade will go down several percent. Okay? That shouldn't happen to anyone, though, if you take the time to study and if you actually put forth effort on the final. So please, if you have questions, come in and talk to me at lunch or after school. If you have any missing tests, let's make sure that gets done next week. Other than that, though, go ahead and work through those couple problems that we had not done right now and continue your review.